Okay, here we go. Today is 3/15/18. Hey, today's the Ides of March. Anybody know what that is?
Yeah. Is it Julius Caesar?
Julius Caesar was assassinated today, like, I don't know how many thousands of years ago, right? About 3,000 years ago, yeah. So if a bird flies into your bedroom and flies across from left to right, you know it's going to be a bad day. It's an omen.
Oh, God.
Anyway, moving on. So first of all, here's some basic things we talked about. Here's our exponential form to our log form, and this is what I have up on the board, right? From exponential form to log form. So we have up on the board in blue. But we learned these log rules today. So whenever you multiply two bases, you'll end up adding their exponents, because logarithms are exponents. In fact, there it is. Logarithms are exponents, okay? Whenever you divide two bases, you're going to end up subtracting their exponents, okay? And we learned this rule just a little bit ago, okay? So let's take a look at example 1. So they do have the same base. We see a plus. We're just going to apply this rule. We're going to go backwards. We're going to rewrite this as a single logarithm. So we're going to rewrite this as log base 4 of 2 times 32. All we're going to do is apply the rule. They have the same base, so we can combine it as 2 times 32, which is log base 4 of 64. Okay. Now, why would we even need to do that? Well, I can actually figure out what this is now. I do know that 4 to the third power equals 64. So the answer to this is 3. Now, I didn't change it to exponential form because I can do that in my head, but it's 4 to what power, right? That's what logarithm. 4 to what power equals 64? It's got to be 3 because 4 times 4 times 4. And by combining them, I was able to do that because before, 4 to what power equals 32? I don't know. 4 to what power equals 2? Right? 1/2. So by combining it, I was actually able to evaluate the answer. Okay, let's look at example 2. So in example 2, I'm going to apply this rule, but I'm going to go backwards. I have a log of the same base, subtracting. I can combine it as a single log. So I'm going to rewrite this as log base 2 of 32 over 4. Okay, which is log base 2 of 8. And I can evaluate that too. That answer is also 3 because I know that 2 to what power equals 8? It's got to be 3, right? 2 to what power equals 8? It's got to be equal to 3. Okay? So it's kind of handy. Now, this is the power rule, okay? Here's the power rule. So whenever you do a logarithm, and this is a really important rule, we're going to use this particular rule probably more than any other rule in this chapter, okay? So when you have a log to an exponent, you float the exponent down. In fact, what happens is the p, just want to show you this, the exponent floats on down. You can see it, it floats on down, right? So if you have a log of some expression with an exponent, by doing the logarithm, it floats it down. Because we know when you take an exponent to an exponent, you multiply the exponents, right? And a logarithm is an exponent. So if you don't get all that, just remember this. Float the exponent down. So we float the exponent down. It's going to now be 2 times the log base 3 of 81. Okay? And if we want to evaluate this, we can. This is the same thing as 2 times 4. Now, where did I get the 4 from? Let's think about that. Okay? Where do we get the 4 from? 3 to what power? 3 to what power equals 81? 3 to what power equals 81? It's got to be 4, right? 2 times 4 is 8. Okay? Now, there's an invisible base. What is our invisible base? 10. Everybody agree with that? So there's a 10 here. And we actually looked at that rule earlier. And our rule was, if you've got the base and the number inside, the answer the same, they kind of cancel each other and you're just left with x, okay? So we have the same thing going on here in this one. We have a 10 and a 10 here. So the answer just goes straight down to 5. The answer is just 5. And we can prove that if we want to put it in exponential form. But why not just use the rule? The rule is simple, right? Right? Now, same thing will happen here. Okay, I have an invisible base here. What's the invisible base here? 10. You guys agree? There's a 10 here. So the same thing happened here. These two, because it's the exponential form, but it's an exponent to the same base, they cancel each other out, and you're just left with 4. And I can prove that later, clarity also. It works the same way as going from exponential to log, and I'll show that to you later, okay? It's actually really easy to prove. Okay, now, example 5.
Question.
Yeah.
Remember, example 3. Can't that be a 9 since it's 81?
Oh,
The square root of 81 is 9.
but that's not a square root, that's a square. So you could do 81 squared, which is a really big number, right? Right? It's a square, so what's 81 squared? But that's not a square root, right? Good question, though. Okay. All right, number 5. Make a star. Okay. Guess and check? No way. Graph it? I could, but no way. We got a new way to do this. Check it out. Remember, we couldn't solve for x before, right? We couldn't solve for x, but now we got a new way. Check it out. I want to use this rule right here. Because if I use this rule, then the exponent will float down. I want to get the x out of the exponent and bring it down. So what I'm going to do is I'm going to take the, watch this, I'm going to take the log of both sides. So I'm going to go log of 4 to the x equals log of 45. Okay? Take the log of both sides. Just do it. Trust me. I want to float the exponent down. I really want to float the exponent down. The only way I can float the exponent down is by making it a log. Okay? Now, I didn't put a base in here because what's my invisible base? And I want 10. You know why I want base 10? Because I can use my calculator, unless you got a fancy one, but we don't have fancy ones, okay? I want base 10 because that's my calculator, okay? So keep it invisible. Okay, now let's apply this rule up here, okay? Apply this rule. So now the exponent floats down, right? So if you've got a log to an exponent, it'll float the exponent down. So let's float the exponent down. So the x comes down. X log of 4 equals log of 45. Okay? How am I doing? So far, so good? So I just applied the rule. Now all of a sudden the x is down. You can solve for x because this is x times log of 4. So let's just divide by log of 4, divide by log of 4, and you're going to get the answer to x. So here at this point, I say, okay, well, I'm just going to divide by log 4, divide by log 4. Now I'm going to use my calculator, but you have to be a little bit careful, and I'll show you what I mean. You got to be careful on your calculator that you use parentheses, otherwise your calculator is going to get confused. Does that make sense? Got to use parentheses, so I'm going to go on clear, and we're going to go on my calculator. You guys can see. Yeah, I'll put it over here. There you go. That's better. So I'm going to go log of 45, and I'm going to close my parentheses. Close your parentheses, okay? Divided by log of 4, okay? So my answer is about much more accurate than guess and check. Much more accurate than graphing it. The answer is 4.74. We can round to the nearest tenth. Well, let's go to thousands. Let's go approximately 2.746. Okay. Now check it out. Let's go back to the original problem. You guys see the original problem? Let's see if I get that up there. Okay, let's go back to the original problem. Can you see the original problem? So if I went 4 to that power, guess what I should get? Clear. So you get 4 to that power. I should get 45. What do you know? Whoa! Well, you can't even see the 45, but it's there. Okay. All right. Super important. This is why we learn logs, is for this example. Okay, so example 6 the same way. It just has one more extra step, right? This is why we learn logs, is to be able to solve for the exponent. Okay, we were not able to solve for x before, but we can. Before we do anything on this one, let's divide by 3, okay? Divide by 3, divide by 3. Let's do the easy part. Divide by 3, divide by 3. So 150 divided by 3 is 50. Of course, why couldn't I do that in my head? I should have, but I will do that in my head. So I've got 2 to the x equals 50. Now, I want to bring this exponent down. I want to bring this exponent down. I cannot bring it down unless it's a log. Once it's a logarithm, I can bring it down. So let's make it a log. So let's take the log of both sides. So I'm going to go, okay, log of 2 to the x equals log of 50. Okay, so if I take the log of both sides, now it's a logarithm. Now I can bring the exponent down. The whole point was it couldn't solve for x when it's in the exponent. But now that I made it into a logarithm, I can apply that rule and I can float the exponent down. Okay, that's why we do logarithms. So then it comes down. I have x times the log of 2 equals the log of 50, right? Divide by the log of 2, x equals log of 50, divided by the log of 2, which is not log of 25. It is not. Do not make this log of 25, because log of 50 is some ugly decimal in your calculator. Log of 2 is some ugly decimal in your calculator. Just keep it log of 50 divided by log of 2, okay? So let's find out what it is. Okay, so clear. So let's go log of 50 divided by log of 2. And I can answer about 5.644. So it's about a 5.644. Okay, thumbs up. Isn't that a cool little trick? That's why we learn logarithms, is to get it out of the exponent. But you can't get it out of the exponent unless it's a logarithm, okay? All right, now, number 7. I suppose if you have a fancy calculator like some people have, you could do this, but she doesn't know how to do it, and I'm not going to show her how. Your calculator will do this. Am I going to show you how? No, I'm going to make you do it my way. But that's okay, because you know what? So if I set this equal to x, and I go, for the x equals 29, I could bring that down, couldn't I? I could bring that x down. How am I going to bring that x down? Make it a log. So I'm going to go log of both sides, right? So if we take the log of both sides, it will float the exponent down. So the exponent is going to float on down. So we're going to rewrite this as x log of 4 equals log of 29, right? Divide by log 4, divide by log 4, and just use my calculator to get an answer. So I'm going to go clear. If I go log 29 divided by log 4, make sure you close the parentheses, right? Then you get about a 2.49. 2.429, okay, approximately. Thumbs up? Okay, so the whole trick is this. If you have to solve for x in the exponent, you need to take a log to get it down. Say that again. If you want x, you want to solve for x, and x is in the exponent, you got to take the log to float it down. I'll say that one more time. If you want to solve for x, and x is in the exponent, you got to take the log of it to float it down. Thumbs up? It's a cool little rule, isn't it? Okay, turn the page. All right, earthquakes. All right, let's see. We got a real life problem here. The magnitude of an earthquake, M, is related to the energy released. Okay, the formula M, which is magnitude, is 2/3 log E to the, divided by 10 to the 8, 11.8. Okay, so we know that the magnitude is 8.2. So this is going to be kind of a long problem, but we can do this. So let's put it by 8.2 in for the magnitude, right? So let's start right off with 8.2. 8.2 is equal to 2/3 log of E over 10 to the 11.8, okay? All right? You okay with what I've done? Now we got to somehow solve for E. Let's do the easy stuff first. So the easy step for me would be to multiply this by first 3 over 2, right? Let's just do that first. Right? Everybody agree that'll get rid of the 2/3? So if I multiply both sides by 3 2s, that'll get rid of the 3/2, or the 2/3. Okay, so I'm going to take my 8.2 and 8.2 times 3/2. I get about a 12.3. So this becomes a 12.3 equals log of E over 10 to the 11.8, okay? All right, let's apply a log rule, okay? Let's apply this log rule here. We'll separate them, okay? We'll separate them, okay? So I'm going to go, all right, I'm going to go 12.33 equals log E minus log 10 to 11.8, okay? I can probably do this in my calculator, can't I? It will be 11.8. But try it on your calculator anyway. It will be 11.8.
Yeah, because of the base.
Right? Same base, right? So, because that's base 10. So this is just, and you can do this in your calculator, but you will get 11.8, okay? And if you want to do that in your calculator, go ahead, but it really will be 11.8 because it's base 10, okay? So let's write this down. Now I got a 12.3 equals log E minus 11.8, okay? Okay, now next step, what do you guys think? Next step, what's the easy step?
Add 11.
Yeah, let's add 11.8. Add 11.8. Oh, let's see, what's that? 33.1, I think. 12.3 plus 11.8. 24.1. Good thing I checked my work, huh? 24.1 equals log of E. Okay, now let's apply this rule. Let's apply this rule, okay? Let's take from log form to exponential form. Now what's my invisible base? Okay, we agreed? My invisible base is 10. So now we're going to go 10 to the 24.1 equals E. How much energy does it take to make an earthquake? That is a very big number. I'm not even going to put that number in my calculator because it won't take it. It's too big. But that is how much energy, and I believe they measure earthquakes in TNT.
But is it like in joules? Because that's not like.
Yeah, it might be joules, but I thought it was in TNT. We'll have to ask Massey, but it seems like it's in TNT. So many tons of TNT. We'll ask Mr. Massey.
TNT measured in?
See, now that's another good question. Thank you, Claire. You do ask awesome questions. Okay, so that's it. We're going to find out. I'm going to Google it here real quick, okay?
Equation too. You're just messing with me. It's not a thing, is it?
Here's our homework, you guys. We have lots of time to get her done.